These next set of questions deal with dividing powers together. Now, dividing powers is almost the same as multiplying powers, except instead of adding the exponents, we have to subtract the exponents. And again, you can only subtract the exponents if the bases are the same. So let's move on to the first question. We have 3 to the power of 3 over 2 to the power of 3. As we can see, our bases are 3 and 2, so they are not the same base. So that means we cannot reduce this down any further, and we're left with 3 to the power of 3 over 2 to the power of 3 as our final answer. Now, moving on to the next question, we have 4 to the power of 3 divided by 4 to the power of 2. We can see that the bases are the same, in this case 4, so that means we can subtract the exponents together. So we have 4 to the power of 3 minus 2. We always take the exponent on top and subtract it by the exponent on the bottom. So 4 to the power of 3 minus 2 is just 4 to the power of 1. Moving on, we have 11 to the power of 7 over 11 to the power of 1. These both have the same base of 11, so we can carry on with the division. So we're left with 11 to the power of 7 minus 1, and 11 to the power of 7 minus 1 is just 11 to the power of 6. Next, we have 5 to the power of 8 over 5 to the power of 8. We can see that both have the same base of 5, so we just subtract exponents. And we're left with 5 to the power of 8 minus 8. 8 minus 8 is 0, so we're left with 5 to the power of 0. But you can also write this as equaling 1, because any number raised to the power of 0 always equals 1. But in this case, we'll just leave it as 5 to the power of 0 for now. Moving on, we have 165 to the power of 13 all over 165 to the power of 4. So both numbers have the same base of 165, so we just have to subtract the exponents. So we're left with 165 to the power of 13 minus 4, which leaves us with 165 to the power of 9 as our final answer. Now moving on to the bottom, we have 6 to the power of 5 all over 6 to the power of 9. They have the same base of 6, so we just have to subtract the exponents. And we're left with 5 minus 9. So 6 to the power of 5 minus 9 is the same as 6 to the power of negative 4. So we leave this as our final answer. Then we move on to 4 to the power of 2 all over 2 to the power of 3. We can see that these numbers do not have the same base, so therefore we cannot reduce it down any further, and we're left with 4 to the power of 2 over 2 to the power of 3. Moving on, we have 9 all over 9 to the power of 4. Now remember, when there's a number that isn't raised to anything, we always assume it's raised to the power of 1. So we have 9 to the power of 1 over 9 to the power of 4. Both these numbers have the same base of 9, so we just continue on with subtracting the exponents. So we're left with 9 to the power of 1 minus 4, and we're left with 9 to the power of negative 3. Moving on, we have 3 to the power of 3 all over 3 to the power of 3. These have the same base of 3, so now we just continue with subtracting the exponents. So we're left with 3 to the power of 3 minus 3. Now 3 minus 3 is 0, so we're just left with 3 to the power of 0, and you can also write this as 1 because anything raised to the power of 0 leaves us with 1. But we'll just leave it as 3 to the power of 0 for now. Moving on, we have 2 to the power of 3 all over 2. Again, when this 2 isn't raised to anything, we assume that it's raised to the power of 1. And they have the same base, so we can subtract the exponents. So we're left with 2 to the power of 3 minus 1, which leaves us with 2 to the power of 2 as our final answer.